Welcome to the Tech Arena, featuring authentic discussions between tech's leading innovators and our host, Allyson Klein. Now, let's step into the arena.
Welcome to the Tech Arena. My name's Allyson Klein, and today I am so delighted to have Jeff Wittich, Chief Product Officer of Ampere, back in the studio with me. Welcome to the program, Jeff.
Thanks, Allyson. Great to be here.
So, Jeff, you were one of my first guests on TechArena. TechArena just celebrated its 1-year anniversary, and we're kicking off season 2. So it's so nice to have you back for another go around to talk about what's going on in the data center. Why don't we just remind our listeners your role at Ampere and Ampere's role in the industry?
Yeah, so I'm the Chief Product Officer at Ampere Computing. And at Ampere, what we've set out to do is to build the compute that's required for the future of the cloud, compute that's both high performance and sustainable. We've long been building high performance processors across the industry to meet the growing compute demand in data centers and in the cloud, but increasingly our ability to continue to improve compute capacity, to improve performance, it comes with another consideration, and that's efficiency and sustainability. We can't just keep throwing more and more power at the problem. We need to actually build more efficient processors. More efficient processors will inherently allow us to deploy greater compute capacity and achieve higher performance.
So, Jeff, I've been following the Ampere story since you guys launched. It's such an exciting entry into the data center arena. You know, we've always talked about when will ARM reach that tipping point, and when will a processor architecture that is efficient and performant deliver to data center requirements. And I think that one of the things that I wanted to start with you on is I know that Ampere has really built that foundation of we're going to do it in power envelopes. We're going to deliver more performance within power envelopes. What has been the reason why you think customers are turning more and more to power being a central design point?
Yeah, well, I think that it's long been a consideration, but it's not really been the main constraint. If you look back a decade ago or 15 years ago, you look with the United States, say as an example, we always had a lot of excess power on the grid. There was no shortage of available power in any of the main regions. Building out data centers that consume more power did increase your operational costs. And there was some logistical challenge of getting more power into your data centers, but it wasn't an inherent limitation. Today, that's just no longer the case. The grid has a lot more demand on it than it did previously. Things like electric vehicles, obviously a very good thing. It's getting people from consuming gas in their vehicle to consuming hopefully much more green energy off of the grid, but it does increase the demand on the grid itself. And, with data centers, continuing to need to meet this super fast growing need for more and more compute, that's just one more constraint. And so I think that as we talk to customers and data center operators, they're finding that it's no longer as simple as just planning out the number of data centers that they're going to build over the 5 or 10 years, or procuring more power we needed from the power grid, from the power company that supplies that area. They're actually getting blocked entirely from being able to build a new data center. Maybe it's because of water concerns, could be because of noise concerns, but increasingly it's because there just isn't any more power to supply that data center. And so people are needing to do more with their existing data center footprint, which is really where we come in. The only option they have over the next couple of years is to create denser and denser compute solutions within their existing footprint, and we're able to provide a perfect solution for that. So I think that's what's changed. It's become not just an economic consideration, it's become a fundamental constraint to the business itself.
What's interesting is I just published my sustainability report on TechArena and talked to a bunch of people in the industry about that. One of the things that I took away was there's estimates that the CSPs, your earliest customers, are looking at doubling their compute capacity over the next few years to fuel the needs for AI. There's estimates, and there was lots of disagreement on exactly how much energy data centers are using. I picked the stat of up to 3.5% of the world's energy, and I think that one of the things that I wanted to talk to you is when you're talking to your customers, where do you see computing going? One thing, I know they're all grappling with the question of AI. Where do you see Ampere having a role in terms of that broader compute landscape as heterogeneity comes into play? And how do you see greenfield versus brownfield in that equation? Are they going to be building out more greenfield data centers? Are they really just going to be managing most efficiently in brownfield, or is it a combination of two?
Yeah. Yeah. All right. Good. Lots to unpack there. Yeah. So I think the AI one is a good one. Obviously that's been, actually one of the things that's fueled this conversation over the last 6 to 9 months, because I think, we've seen similar stats, somewhere between 3-4% of the world's power is being used by data centers. And AI just suddenly created this massive demand for more and more compute. And unfortunately today, a lot of that compute that's being used isn't that efficient. It's a lot of, really, really power hungry GPUs that are being used mostly for the training phase of AI. Now, the good thing is that as the AI opportunity matures and we move a little further along the hype cycle and get from kind of the research and R&D phase into the real deployment at scale phase, the training piece will become a smaller and smaller piece of the problem.
Right.
Everyone's concerned right now about how they train their multi-hundred billion or trillion parameter model. And the fastest way to train those models today is to just throw an amazing amount of compute at them. And it's expensive and it consumes a lot of power. But the good news is you only need to train this model once, or maybe just once every 6 to 12 months. So that's good.
Right.
So where Ampere comes in is as customers are looking to move from that training phase over to the inference phase. And inferencing is inherently a scale workload, one that is being run all around the world, close to the users. And it's a different type of compute task, where training is one really, really large compute task that's run once. Inferencing is a smaller task that's run maybe even millions of times a second. And in that case, you're looking for compute that can be pervasively deployed everywhere, that's economical, and it's also really efficient. And so we've helped customers to move from that big GPU training phase to now deploy their models on lots and lots of Ampere CPUs that are sitting all around the world, that are consuming considerably less power, and that are allowing them to bring down their inferencing costs, in some cases by as much as 5x or more. And we've got a lot of really good examples of customers that are doing this from people like Wallaroo. I was actually just out in Europe recently, in France at an event, and we had a customer there named Lampy that's deploying on a French cloud service provider scale. So there's a lot of appetite for this, and frankly, this is a major global problem that we need to solve, because that 3.7% power consumption today, it's clearly not acceptable for that to go up to 5-6% over the next couple of years with increased AI demand. We need to sit at that same level, if not even shrink our power footprint over time.
And obviously, one of the key components is the amount of energy a microprocessor consumes, but there are other topics that are entering the sustainability zone. One is code efficiency. The other is carbon utilization efficiency. What is Ampere's take on both of those, and how are you engaging the industry to work on those challenges?
Yeah, no, that's a really good question. Because I think, when you're right, at the start, what most people think about first when they think about power consumption, they think about how much power is actually being consumed by operating the CPU. And so obviously if we can bring that down, which we are, that's a big help. The second piece of it is what is the amount of power that needs to be consumed to cool that processor. So if we can stay within a reasonable thermal envelope, running processors that only consume 1, 2, 300 watts, that's a lot easier to cool than a processor that's consuming 5, 6, 7, 800 watts. And so we can also bring down the power consumed for cooling the processor as well. But you're right, you bring up two other areas as well. One of them is code efficiency, and the other one is utilization of the hardware. When we look at from an AI perspective, that's kind of an easy one to see where code can be optimized to be more efficient.
Mm-hmm.
When you look at these models, say multi-100 billion parameter models, I've talked to a couple of companies that have trained models of that size, and they said that now that the model's trained, you can actually determine that maybe 95% of the parameters in the model don't have any bearing on the accuracy. And you wouldn't have known that a priori. But now that you've trained the model, it's clear which parameters matter and which ones don't. And so now they can go in and they can economize those models, make them smaller. Smaller models require less compute, less power to run. And they can do that with no loss of accuracy. The other thing people are doing is quantizing their models. So instead of running, say, with FP32 precision, running in FP16 or bfloat 16 or even int 8 or int 16. And that oftentimes results in no loss in accuracy, but requires a lot less computing power to go in and run those models. And that's an area where we've also been really focused with our customers. We have native support for all of those numerical formats on our Ampere processors. So that's definitely a piece of it, is economizing the models. And I think you're going to see a lot of this where those multi-100 billion parameter models, they exist, but many of the new models that come out are actually smaller and smaller models that are much more economical to run.
That's fantastic.
But also the second one, though, that you mentioned is the utilization one, which I think is really important. This is a key reason also why using more general purpose hardware like CPUs is really powerful, especially for AI inferencing. They have more than enough compute power. They're readily available around the world. They're generally more efficient than GPUs, and you can run them with very, very high utilization. If GPUs have two flaws in this space. One, while you may be able to heavily utilize a GPU on a training task because it's running for many, many days, weeks, months, you can ensure that all of the cycles are being well utilized. Inferencing is different. Inferencing is a much less dense problem, and you're often not fully utilizing the GPU, even when you're running inferencing all the time. And then the second aspect of it is you're probably not running inferencing all the time. You clearly, there must be some other element of whatever service you're running, a web server, a database behind it. There's something else there. And over time, the balance of demand between different workloads does change. CPUs give you the complete flexibility to run any of those workloads and keep that CPU fully utilized, whereas a GPU isn't going to be utilized when the web server demand, for instance, increases. So those are key parts of the efficiency story.
That's a really good point. And I think that that's so pragmatic that we forget about it, right, Jeff?
Mhm.
It's like, yes, you can use it for other things.
Yeah, it sounds
You have the opportunity.
Yeah, it sounds so simple, and it
Right.
is. But yeah, we forget about it because we're looking for some, a more complicated solution, a shiny object out there, and we forget that sometimes the best solutions have been sitting there right in front of us the whole time.
Now, you mentioned customer examples, and I'm so excited to hear you talk about them. Ampere has been making incredible strides in data centers. And, I was at your analyst event earlier where you had Oracle on the scene talking about, development of optimized code on Ampere solutions. There's just a tremendous amount of momentum in the marketplace for you guys. Tell me about what 2023 has been like. And, where do you see Ampere headed as we pivot into forward looking into 2024?
Yeah, Alison, 2023 was a pretty pivotal year for Ampere in a number of areas. Number one, it's really the year that sustainability became front and center in the data center space. So no longer was there kind of any doubt as to whether power efficiency mattered. And so the strategy that we had employed from day one to build an incredibly efficient processor mattered more than ever in 2023. And just the rise of compute demand from AI just further accelerated that. The second thing is that 2023 marked a big year in terms of the pervasiveness of Ampere solutions across the market. Whether it was big hyperscalers like Oracle Cloud, Microsoft Azure, Google Cloud, Tencent, or other regional clouds like Hetzner in Germany, Scaleway in France, Glesis in Scandinavia, LeaseWeb in Netherlands, you name it. There are clouds now around the world that are deploying Ampere CPUs. So it's never been easier for people to gain access to this technology. And we're seeing rapid adoption in places like enterprise private cloud, using solutions from OEMs like HPE and Supermicro. So that's been really rewarding to see that anyone now can get access to an Ampere server or an Ampere instance in the cloud. And now we're really seeing that even expand out into the edge. So 2023 was a really pivotal year in terms of pervasiveness of Ampere solutions. And then I think the third thing that was really important from an Ampere perspective and very strategic for us is that 2023 marked the year that Ampere One, our next product family, launched. And Ampere One is particularly important to us because it's the culmination of years of engineering work behind the scenes to build our own core that uniquely addresses the needs of efficiency and high performance in the cloud. And now you're seeing Ampere One deployed at Google Cloud and Oracle Cloud. And it's that innovation across the whole SoC all the way down to the core that allows us to provide a unique solution in terms of scaling out to a higher number of cores than anyone else, 192, hitting efficiency points that just aren't possible with other architectures and other designs, and delivering some really cool, unique features to deliver better manageability, better security, better power efficiency for cloud users. Features that some of them have really, really sought for a long time. Not to go too deep on that, but a great example of this memory tagging, something that Oracle had asked the industry for over a decade, which allows them to both ensure that code is working properly, but also protects against things like buffer overflow attacks that could affect users in the cloud. And it's just something that doesn't exist in any CPU. So I think across all those areas, sustainability being crazy important now, pervasiveness of our solutions and of the software ecosystem around it, and third, taking that next strategic step with our next Ampere One product. 2023 was very, very important for Ampere.
That's amazing. I think that you are ahead of where I thought you would be by the end of 2023, and I can't wait to see what you guys deliver in 2024. Please keep coming back to the TechArena and keeping us apprised of the progress. You mentioned the 192 cores. It's an impressive feat. I actually read that you're pushing the limits of Linux, and
we are.
I love that.
Yeah, no, we're the first people to push to 192 cores and even more. Obviously, we need to upstream changes to the Linux kernel a bit before future products come out. So yeah, if you pay attention in that community, you'll see that we were pushing for the enablement of even higher core counts in Linux. So yeah, we're pushing the industry to some places that it just hasn't been. Really, really exciting stuff.
I guess I know where you're going then. That's so exciting. I love to see it, and I love to see the pressure you're putting on the market to think differently. That's really refreshing. I only have one more question for you, Jeff, before I let you go. Where can folks engage your team and find out more about the Ampere solutions, engage with you in a POC or trial and talk about it?
Yeah, there are a few good places. Probably the best place to start is to go to amperecomputing.com. There's a number of ways to engage through amperecomputing.com. You can either contact our sales team or some of the other members of Ampere. There are also links out to a lot of places where you can go and get trial hardware or get started in cloud, even for free. There's free instances out there from various cloud providers. The third area is our developer program. There are ways to engage there across our developer forums to start to learn more about what you can do with Ampere CPUs. So a number of great places to get engaged. And we hope to see more and more people engaged in using Ampere processors out into 2024.
Awesome. Thank you so much for being on the show today. It was a real pleasure.
Well, thanks, Allyson. It's always great to be here on TechArena, and keep inviting me back. It's always a great time.
Thanks for joining the TechArena. Subscribe and engage at our website, thetecharena.net. All content is copyright by the TechArena.